Hey guys, welcome back to the channel. I have another interesting video. It's going to be a test on a computer that was sent to me. Dylan Hendricks, this is your computer. And I'm going to show you a little bit of the communication that we had before he sent it. Where he said, I've seen a couple of your videos where you actually look like you fixed a computer that no one else could or can fix. I said, well, I try. It's not always the truth, because there is always limitations, right? But I try my best. But Dylan, your computer is working. So in this case, yes, I have a very good success rate. There is sometimes where it cannot be repaired. There's nothing I can do, but at least you will know that if I said it's not repairable, it's because it's not repairable. It's not like other facilities that are just trying to repair this with software, and then they tell you the computer is no good and you need to buy a new one, which is not the reality. I have fixed, hundreds of computers that a company in Florida, not in Florida, in California has deemed not repairable, and I have repaired probably 99% of what he has said that was not repairable. All right, let me show you the connections. This is for him to see, and also you guys, because each of these computers has a very unique part number. Let me just make sure this can focus. Come on. It's going to be a little hard to do. This number right here, I always pick up from after the letter A, 92020111. That is very specific to this computer only. And this is a MEFI 4, but it's a MEFI 4A, 12575479. All right. So, well, you can see right now I have the fuel pump, injectors, and I can put even the picoscope and diacom, which I have connected. We can see the pulse width modulation of the injector signal, the pulse width, and I have put in there on the bottom of the screen on the bottom right. That's the oscilloscope. The minimum and maximum of each channel. So you can see that we have battery voltage and they're being pulled down to 0. And the signals are very nice and clean. So the computer itself is actually not really many hours. It has 186 or I think it was 186.4 when it got here. We'll see how many hours we got now. I think we got 186.5. So it's been running for like 10 minutes or so. And it's a 5.7 Indmar. I don't know if I tell you that. These are use a EST ignition system, and you can see it's working good. So, but I'm going to show you, and I don't have my iPad to show me if you guys are seeing what I actually will show you, but I think it's still safe to do. All right, so I got it in the screen. This is the repair form that he's in. As you can see in there, he's from Fredericktown, MO, and his name is Dylan Hendricks. It says no communication, all injectors have stayed on, not sure. Monsoon 335 5.7 liters, and the serial on the engine is a 1026 3880. Going back, this is when I got the computer. You can see in there everything connected, and the same part number and everything we see before when I show you. And this is when I first connected it, completely dead, no communication. We can see in here on my simulators all the powers and everything on, but no fuel pump and no communication. So you can see all the wires in here on the serial. This is the serial diagnostics that MEFI 4 uses. And again, no communication. Let me see what else we have here. Oh yeah, these are the emails. The first one, it happened on July 10. He said, I seen a couple of your videos, and I have currently got a MEFI 4 that someone looked at it and said it was not repairable, but you seem to fix the one people deemed totally broken. If you could give me a call. Oops, and I have his number. Okay, well, I'm sorry, Dylan. Then the next, which is not like 5 days or so ago, hopefully my ECM made it to you. I lost tracking information. The yellow tape in front is from me. I wanted to see if the ECM had water intrusion before I send it to you. I send it off to you. Send it off to anyone. Sorry about that. Yeah, that's the last one. I'm sorry I got the number in there, but I don't think it's going to be many people trying to call you. I will try to blur that out. All right, so let me turn the computer off one more time so we can see the computer. I'm going to put a few pits in the screen. Yeah, you can see in there how it's losing the communication, and that is normal because I turned the computer off, right? So that is very, very normal. I'm going to turn it back on. We can see the fuel pump immediately coming on, and then I have to reestablish communication because I waited for too long. But let me do that. Yeah, you can see in here it is disconnected. So I'm going to start from scratch. Let's say, oh yeah, the computer is running. Yeah, I got the computer running. I'm sorry, guys. And sometimes I get distracted from trying to collect my information for you, right? Or think on what I'm telling you. Yeah, the computer running. We're going mode 1. And again, I'm sorry if you're not seeing that because I cannot see the screen the way it is. And I am connected to the screen right now, to the computer. Make sure that you can see that. Yes, you are. All right, so what I have to do is turn the RPM off, and you can see when I do that, the fuel pump does a prime, because it's not really common, for the computer to see that you lose the RPM without switching the ignition off. I just turn the crankshaft position sensor signal off. I'm going to again do the same thing to lose communication. You see that in there. I'm going to establish it so I don't lose it. And then it's going to try to establish communication, and now we're connected. You see it's still connected. Why? Because in the last one, I waited for too long. But yeah, so that is all good. I'm going to select 2 pits in here so you can see that, because otherwise it's a little hard from your distance. So we're going to see the RPM, and I forgot to show you also how many codes we have in history. So he had manifold, pressure sensor, voltage low, EST has an open circuit, injector A and B open, engine over temperature telltale set, general warning telltale set. So I'm going to erase those because I know that nothing is in here, because we saw those injector signals and they're nice and clean. So that is definitely either on the boat or when this problem happened, because I can tell you, Dylan, the problem that happened on this computer, it could be potentially a sensor shorted. So make sure that you check your 5-volt reference before you connect this computer back in the boat to make sure the 5-volt reference is not shorted to power. And when I say that is pick up any of the sensors that uses the throttle position sensor is the easiest to get without even the computer. In there, you're going to have sensor ground, the signal, and the power. So I can send you and show you, which let me just get that on the screen for all of you since I, bring that up. So give me 1 second, guys. So I'm going to go into the connector. So this is a 5.7. One second, guys. All right, let me move you to the screen. So here, this is the connector J1 and J2. The computer has an ear. Let me get back to you and make sure that you are seeing that. Okay. The computer has the ear and 2 holes. The connector next to the 2 holes is J1. The connector next to that ear is J2. So you know where those are located. All right, let me go back to that picture of the connector. So we talk about the throttle position sensor or the test you can do. If you want to do it on the computer, which is perfect, you can do it in there with the computer connector, with the computer disconnected on the computer connectors, right? So this is probably your best bet to do. Like that, you can see if it's any short to power or short to ground. So we're going to go over to J2 connector. J2 pin 2 is the 5-volt reference, and connector J2 3 is the sensor ground. So those are the 2 most important voltages and grounds for the sensors, right? So we're going to, with the computer disconnected, you're going to turn the ignition on, and you're going to put a multimeter here, first of all, it should read 0 volts. So you're going to connect the lead of your multimeter. Let me get back to here. Actually, to here. So I'm going to use a multimeter for the example to show you. You got a regular multimeter. You're going to set that into continuity, and you're going to make sure that it is in beep mode. So when you set up a multimeter into continuity, this is a little entangled. So give me 1 second, guys, because I cannot do that. Perfect. So in the case of a Fluke multimeter, usually Fluke has the resistance in the same place that you're going to have it. Most multimeters do too. So you're going to have the resistance. So if I touch this, now you can see that it will read resistance. So it's almost zero ohms. If I press onto whatever that line is, like look like a sound here, that symbol, right? That's the sound symbol. So you look for that one. In my case, all I need to press, I think, is in this one is in a function. When I press in there, now you can hear the beep, hopefully, because this microphone has a noise reduction part. So what you're going to do is the negative of the multimeter always on the battery ground for the first test. You're going to move it then, when I say so, over to the battery positive side. All right. So and you're going to use the other lead side onto the computer connector, right? Which is the red part of the multimeter. All right, going back into that picture. All right, so with the negative side of the meter on the battery negative and on continuity, we're going to touch into J22. No beep, that's a good thing. We're going to touch into J23. It should beep. If it doesn't beep, we have an open onto the sensor ground. J23, it has to beep. If it doesn't beep, we have an open circuit. That's a problem. And that could potentially be that wire is shorted to power and no longer is a ground. And it has to be a ground, right? So going back into the fiber reference on either one of those wires, let's say you do the test and there is no continuity into J22, which is the fiber reference, and there is continuity into J23 in sensor grounds. Okay, you will say, okay, well, Mike, that's good. Yes, and still we need to proceed with more. Once you have that meter connected and you have that beep on the ground, you're going to start wiggling the harness with the ignition on, right? Wiggling the harness to see if by any chance or by any time, whenever you're touching the harness, you're not just going to grab the harness. No. You're going to go into spots close to heat or corners, any metal clamp, plastic wire tie, or something that you see abnormal on the harness. Try to wiggle it in there and see if by any chance it changes. If it doesn't happen with the meter connected to ground, we're going now to connect the meter into power. The problem with the meter into power, you need to turn the ignition off and you need to disconnect the battery. Why? Because in this case, the meter is in resistance mode. So if we do the test on continuity with power on the wire, it will be no good. So you need to remove the voltage out of the equation. In this case, again, disconnecting the battery, and you're going to use an alligator clamp or alligator probe to clamp it into the battery positive, and you're going to do the same thing on continuity in the two wires. It should be no continuity, right? If it's continuity, it's shorted. That's it. We need to repair the harness. If it's not shorted and it passes the test good, we're going to do the wiggle test. That is the best thing you can do. I usually do a test light test, which is connecting a test light to ground and the other side of the harness into power or vice versa. But in this case, it's not really necessary because all we're looking for is to short to power or short to ground. So the next thing that we need to do in this case, now that you have that, yeah, you are here, because again, I'm a little worried you guys are not seeing what I'm seeing because I don't have my iPad. Let me see if I can make it work. The software is called Space Desk. It's very good, but so for some reason, I don't know if it's my computer that disconnects by time and I have to reboot the computer. And yeah, it is not working. All right, so either way, the next test that you need to do is to make sure that you don't have a shorted sensor. Yes, there is still an easy way to do it right at the harness or the connectors in the computer. Because let's say, we want to make sure that we have no sensors that are shorted to ground. And then when you connect those, it's taking the computer down, right? So going back into that same capture or that same image, please, if you want, take a picture of that image that I'm showing you here, because that is a good, easy way to find out. I have marked all the signals. Come on, why is it not showing me this images? Okay, finally. All right, so as you see, I have put in there communication, fuel pump, injector, IAC, and so you have most of the main signals in there. So ECT, engine coolant temperature, MAP, manifold air pressure sensor, CKP, crankshaft position sensor, EAT, intake air temperature sensor, TPS, throttle position sensor, and there is any other one. Well, we got the NOx sensor too, and J117 that I don't have marked in there. And that's it. That's pretty much. Oh, and then the cam sensor on J232. That is a very important signal as well. It all depends on the setup you have, right? Because some don't have the signal. But if you have it, then check that one as well. So what you're going to do is now with the connectors on the computer is still unplugged, you're going to connect the battery back up, and you're now going to do the same test that we did before. With the multimeter connected into ground, right? With the negative lead into ground. And continuity, we're going to touch J232, make sure there is no beep. We're going to J223, make sure there is no beep. J221, and so on, all the sensors. If it's no beep, still that's a very good sign. We need to do in each of those wires the same wiggle test to make sure that by any chance, at any time, the harness is not rubbing or hitting into there and then shorting out a sensor and then shorting out the computer. All right, I'm trying to give you as much information as I can so you can successfully check your boat, because something definitely damaged this computer. And we want to make sure that that doesn't happen again, because burn computers, no warranty. Defect of labor ship on even a component, and I don't make the components, and I want to address this because sometimes customers get upset because they get the computer back and they put it and it worked good for a few hours and then it fails. If it's something that I did labor-wise, I will say, yes, well, I did something wrong. And I'm very honest. I'm very transparent. If I did something, I said, yeah, my mistake, 100%. I'm so sorry. I missed soldering. And I have said that in multiple videos. I think for lining, I forgot. I forgot. I did the solders, and it's such a hard component to solder because the legs are under the component, and I missed one, and it worked good here. And then when I took it over and sent it to the customer, it started and run for like 2 hours, and it died. He sent it back, and I analyzed it better, and it was a loose pin. So now I'm more careful with that, and that was my mistake, 100%. But if a component fails, what am I going to do? I don't make the components. And yes, I warranty it. I will put a new component, no charge to the customer. But I hope that you understand that part too. It's not my mistake. We're in this together. If a component fails, it's a component fail. That's what the warranties are for. But please don't get frustrated. Don't get upset. I am very good in my responsibilities with customers all the time. I get very good reviews because I'm very confident of what I do. I am very responsible. So please just take that in consideration. I know that maybe by the time you reach me, you have been burned by 3 or 4 companies that they have take all the money away from you. That was not me. So please don't take those frustrations on me. Okay. All right, guys. All right. Let's do a test more. Right. So I got the engine speed. I think I was going to put another one. I don't really think we need to, because I think that the size of this image and everything right now, you can see really well. So let's run it again. So I'm going to turn the ignition off. Ignition back on. We can see the fuel pump in there. And let's run this again one more time. We can see the engine speed perfectly working in there, 601 RPMs. And the signals of the injector, like I said, very nice, very clean. So this is not a problem. I don't like that I can see 6 volt codes still. Let me see what this computer is saying in there. Yeah, it looks like we have 6 volt codes. ESD has an open circuit. I can disregard that one. Injector A, injector B open. Manifold pressure low. Manifold pressure. What is my manifold pressure and where is it? Because I got 12.7. So the manifold pressure is not low. I'm gonna move you over to that so you can see. Oh, and I actually probably have made a mistake in showing you stuff when I have those images on the screen, because it is where I sometimes forget that I have the picoscope and the diacom. I'm not sure if you were able to see everything that I was showing you, but I'm sorry if you didn't. All right, so let me work in here so you guys can see too. So we got 12.7 inches of map pressure, and I can change that. Let me change it. I'm gonna go up and down. I usually keep it at 12.6 at idle, so that is reading fine. Fiber reference and sensor grounds are good. I'm gonna close this so we don't need that when I'm doing it here. So let me erase the phones one more time. So yeah, 41. Yeah, I can disregard that one, because usually, 41 ESC system has an open circuit. It all depends on the ignition module that I have connected. It depends on the computer manufacturer. It might not like that signal. It doesn't mean that anything is wrong, because we can see here the computer is running. Let me put the diagram again in the screen. Oh, I minimize it, so it has to be full. And get the picoscope as well. But yeah, so looks like we have now 1 fault code. So okay, that is, I was thinking like we might have another problem, because sometimes, and I have seen, computers that even the injector signals are good, but the confirmation for that signal is not good. And that's when you get sometimes injector A and B open and the injectors are working good. It still is a problem inside the computer. If you get that, I can definitely repair it, not an issue, but it is definitely the computer. And it's not the first time the customer is like, my boat is running great, but I cannot get rid of the injector A open and injector B open. I'm like, yep, it is the computer, the confirmation part. It's not really hurting anything, but the problem is you're going to have a bip here and there, and then you don't know if you have a problem that you need to stop because it's a temperature or something, or you just had the same fault, and the people get upset. And I mean, I know that's got to be just annoying to have something like that, but definitely I can repair it. It's not a problem. All that can be fixed. Yeah, this is working great. So let me turn it back on again. Sorry, back off. Right, we lost the synchronization. Turn it back on. Fuel pump is working good. And we're going to start it one more time. This time I'm going to increase the RPMs. So keep an eye on the RPM, which I should keep. Maybe let me just keep that one so you guys can see the RPM from the distance. Yeah, that's probably good for you guys. I'm going to move it so it's not in the way of anything. Like right there, right? Yeah, that's perfect. All right, I'm going to increase the RPM. $3,100. Let me change the throttle accordingly. 35%, that's fine. And I'm going to increase the manifold air pressure. which I need to find it. 15, 17. I want you to see the on the bottom signals. Now we have more signals. Obviously, the boat is running or the engine is running in a higher RPM. With the changes on the manifold air pressure, the injection millisecond went from whatever it was 2.8 or so to now 5.6 milliseconds, and that will happen normally as you accelerate. This is a completely nice looking waveform. Everything is working perfectly, not a problem. So right now we have, after turning it off and on, we have like 2 minutes of running time. The total amount of hours is 186.5. So I would say maybe 20 minutes at the most we have run the computer in the video, right? But yeah, everything is working great. I'm going to move one of the channels in here to the coil so we can get to see the activation of the coil, which is very different compared to the injection. But yeah, all is here. All is working 100%. No problems. All right, yeah, everything is looking great in here. I don't see no more problems in this computer. Like I said, I can disregard that fault, and believe me, I have great experience. I know what I'm talking about when I give you that answer. This should not go into a fault in the boat. Not a problem at all. This is just because, again, I'm using a Volvo Penta ignition module, and this is a Malibu or Indmar, right? But yeah, everything is nice and smooth. Let me bring the computer back to idle. And let's bring the signals down to normal. Yeah, put the manifold air pressure around 12.5 inches of mercury, and you see now the injection millisecond of 2.9 milliseconds. I had at the throttle position of 6.6%, but everything is working perfectly. All right, Dylan, I'm very happy, very pleased to give you the good news that your computer is fully repaired. I'm glad that I was able to, because he got high hopes. He asked me, how confident you feel about the repairs. I said, 80-20. There is, some components inside this computer, which I have shown in all the videos pretty much. They are crystal made, that they're not replaceable. They don't sell it either way, right? If one of those is bad, that's in the time that I said, okay, that is not repairable. And that is the only time. But before the rest, or after anything else, I can pretty much replace and repair, and the proof is in the pudding. I have this one, another good computer. Another bad computer that was going in the trash because somebody else's recommendation, that is now fully repaired. We'll go back to a happy customer. Again, guys, thank you so much for visiting the channel. Please don't forget to subscribe. That really, really helped my small business. And that's how you find me, right? So if you're here and you have not subscribed, just please do so. It's for free, and that really helped me a lot. Thank you so much. See you next time. Bye-bye.